Okay, Joe.
All right, thank you. Okay, so we have a preliminary version of the AllJoyn code generator. It currently produces code for the thin client. And the thin client was our first target because some of the stuff in there was a little complicated to do manually. And so we targeted that first. And I'll show you some examples of what that code actually looks like later. But in general, the code generator could have some great benefits, particularly when you're trying to run on multiple platforms and trying to get a lot of people up to speed on this stuff. You can use the code generator from a single source XML file to produce code for multiple platforms. And that will enable you to do tests on a bunch of platforms quickly. People that are trying to write code for AllJoyn can create their own samples. If they know how to write just a little bit of XML, they can then find their own sample code that targets just the things that they're looking at. We can also do prototypes rapidly, and again, test it on multiple platforms with a tool like this. And then another thing we've seen is that sometimes a real-world application that you're working on isn't working. And we're not really sure, is it inside the app or is there a problem in the AllJoyn code? And you can generate a quick and dirty app that exercises the AllJoyn code for the thing that you are suspect of, and you can see if this known good code, which it should be good, is working under AllJoyn, and then you can help isolate that problem some. So the question is then, how do we write this XML code? What does that really look like? And how do we go about writing APIs and stuff? The XML that we're using is based on the dbus specification. And if you go to the link to the bottom of this page, you'll see in great detail how to do things like properties and signals and different argument types, all that sort of thing. And I've done just a very simple case here. And so you have the different nodes, you have the interface names, and you can have multiple objects, properties, signals, various argument types, including structures and arrays, that sort of thing. It's all specified in the XML. And then the code generator will read this XML and spit out the code that represents both the service and the client side of this service description. And then you can run that code, and both the service executable and the client executable, and they'll start talking to each other. And you can see that it goes across the bus just as the XML had specified. So that's kind of a top-level view. Now we're going to go down and talk about how you actually install the code generator. The code generator is developed with Python and Cheetah. You don't really need to know how to use those unless you're going to start writing your own language bindings or something like that, or extending the code generator. But you do need the runtime libraries from both of those products. So install Python and then Cheetah from ordinary standard download locations, and then you can get the code generator source from the AllSeen Alliance, and then build the code for that and install either the Win version, Windows version, or Linux version. If you're inside Qualcomm, we do have some install programs available on internal servers that you can download that are a little bit more up to date than what the code is that's actually on the AllSeen site at this point. The code generator is entirely command line driven. There's a help option, and you'll see all the different options that are available if you do a -- help. But there's only 3 required parameters. One is the target. That's currently the -TC target for thin client. And then there's the well-known name, and that would be something like test.joe or something like that, whatever the well-known name you need for the service, and then the XML source file. Here's another very simple XML source file, and for the code generator, you would invoke the code generator by typing ajcodegen.py-ttc for target of thin client, the -w for the well-known name, in this case codegen.test, and then the name of the XML file, void.xml, and it will spit out the code in a second or two into the default directory. But usually what you want to do is put it into a different location such that you can compile it easily. You don't generally put it in your default location. You then run the scan script for building your thin client code, and if you've made a slight modification to your scan struct file, it will build the generated code as well, and you'll end up with a service main and a client main executables in your target directory. There's also a -r flag you can specify to the code generator, and what that does, it actually executes the remote procedure calls and sends out signals and does all the calling of those service APIs and methods that you created stubs for without the -r. So it'll actually create dummy variables, increment those variables, and pass them back and forth as if you'd actually written an app around those service methods, properties, and signals. And again, you can extend this XML considerably and see the debug specification for the details on how to do that. The modifications I was telling you about to the scan script file, the construct file, is the code generator default directory. There's a construct file, and you'll add, in this case, I've created a CodeGen subdirectory under there, and then put in and specified the scan script file that is created by the code generator. And what that'll do is when you run scans, it will invoke the compiler to produce the client main and service main that the code generator had produced. So I will just do that real quickly here and show you what actually happens here. So here's invoking the code generator for thin client with the run flag and putting the code into the CodeGen subdirectory under the thin client root directory, and I'm using an XML file I called T1. So you produce the code, and now I will do the invocation of the compiler. And we've produced some code. Go into the CodeGen directory, and we'll see the 2 executables. We can run the service. And then I'll go to another directory. I'll run the client, and we will see that the client and service are talking back and forth to each other. And we see various variables here that are changing with each call. So it's actually incrementing variables, changing the state, and calling, the service is calling, the client is calling to the service is sending out signals, and we have a very simple working app. So this is just the first version of this. We expect that there'll be need for other language bindings, and so we made the code generator easily extensible. The core of the application is written in Python, and that does the XML parsing and builds structures and creates a internal representation of the service for both the client and the service side of things. And then that drives a template language, which is the Cheetah. And that is basically code that's like C code or Java or C# or whatever you might want to have, decorated with some template specific bindings, such that you can pull the structure from the XML out of the Python code and embed that into this, what looks very much like C code, Python code, that sort of thing. And I'll actually show you a little bit of that. So this is Cheetah code, but it looks a lot like C code because for the most part it is. We have some decorations here, like here, that is the Cheetah stuff. Here's some more Cheetah code in this area here. So that we can write, for the most part, in the native language that we're targeting, and then pull the different objects, the properties, the interfaces, that sort of thing, out of the Python code and create a useful program. So if we go back here, we'll take a look at client main.c over here. And we can go up to the top here and let's see if we can find something here more interesting. So here on the left, you see we're building a switch statement, and there's a bunch of Cheetah code embedded in the template that ends up being changed to these defines and this sort of thing here, so it becomes standard C code. So you can do the same sort of thing with any other language. You have your main code that you're going to write, and then you just have to decorate it with some of the cheetah code to generate the ultimate code that you're going to be compiling. So it makes it a lot easier than trying to write a bunch of strings in your, if you're writing this app in C++, that sort of thing. You'd end up with all these strings embedded in your code rather than having a little bit of template code embedded in your C or C++ target language. So it makes it a lot easier to visualize what's going on there and to write the code and to debug it and to maintain it. So, like I said, we currently have the thin client working. There's a few limitations on it. It currently doesn't handle nested structures, and there's a few other things that we probably ultimately will fix, but until we start getting feedback and see what people are really interested in and really need, we'll probably work on other language bindings. We have our own ideas on what those language bindings are going to be, but the priorities and stuff will be fleshed out with our next planning session on version 14.06. Are there any questions about the code generator? Great. Any type messages or anything?
If you can show XML you use to generate the code.
Sure. I'll bring up the XML I used for that particular test case. So it was pretty simple XML, but I had a method called ping. It has an input string, an output string, and then there was a signal which had a bunch of different variables of different types. So we had the S type is a string type, an I is an integer type, D is a double type, and a B is a Boolean type. And we parsed that, and we produced both the methods on the service and the callers for that method, and then the signal receivers on the client and the signal senders on the service side. You can also do properties, but I didn't include a property for this particular case. Are there any others?
Once again, if we can see the output of those.
Was it fun? Yeah. Was that fine? Sure. So, I think I already have client main up. Yeah. So here's client main, and you see probably the most interesting thing there is the switch statements, and then there's also, if we go to common client service, these are some of the difficult things to do in client is to produce some of these tables, and that's done automatically now. So we have, like here, here's the signal with its output values, both the name and the value, the variable name, and the types. We have our tables for the objects, all that sort of thing there. And then I'll show you some other things that are somewhat interesting. This is where the run flag will produce most of its output. So we have an actual call to the interface right here. Here's the ping method, and it's calling ping with the bus, the session ID, and the input string. And it had generated the input string up in here. And then when it gets the return value is this. This is back in client main. It hands the message to the reply handler, which here's our reply handler. So it gets the message, and it unmarshals the args, and then prints out the result here.
Is there anything hard-coded in code generator which end users should know in general?
Well, certainly there's a lot of things that are hard-coded. You know, probably the one thing that you might want to change is the port number. The port number, I think, is specified in here. I'd have to find it again. Service port. Yeah, the service port is a defined, which is currently, it's hard-coded to the 24. We also have some timeouts and stuff like that that are hard-coded, but they're all in the file, and those are easily changed you know, when you start modifying your files. So I don't think there's going to be a big issue on things like this. Other things that might be a bigger issue are things like if you're going to be changing, you're going to be adding parameters, that sort of thing, and you have already modified your file, and then you do a code generation again, it's going to overwrite your existing files, and that's something you're really going to have to watch out for, is that it overwrites the existing files, so you should have made copies and then just look at the differences between the changes you made and then what the output's going to be if you've added a new parameter or something in your XML file.
Okay.
Hey, Joe, just so I understand that last comment, so you're saying that if someone were to modify the generated file, that they'd have issues, or because I'm assuming that if they added the parameter to the XML, you would just regenerate the code and everything would be fine.
I would regenerate all the code, but suppose you had added a bunch of your own code in there for doing something very specific for your application, and then you decide, oh, I needed to add another parameter, another method, or something like that. When you run the code generator again, it will overwrite whatever files that were in that directory. So
I see. So
if you've made modifications to those files, they're going to be in jeopardy.
So are you saying that in normal development that it's expected that one would have to modify the generated files to do what they need to do, or can they?
For a real-world app, yes. What this does is basically create all the AllJoyn specific stuff. But then if you're going to, when you receive a method call, for example, on the service side, it might actually query the refrigerator or something and find out, what the temperature is. And that's refrigerator-specific function is not something the code generator is going to generate. So that if you made that modification and then add something to check to see if the light's on in the refrigerator to the XML, when you run the code generator on the XML again, it's going to put a generic method in there and overwrite the specific code that you put in there to see what the temperature of the refrigerator was.
I see. Okay. So it sounds like you're saying that in normal operations expected for me to modify the generated code. Okay.
Yeah, basically this produces a sample.
This is
a very quick and dirty way to generate sample code, and then you borrow from that sample code to do, whatever it is you need to do. So it's a great starting point, but it's not going to write your entire app for you. Are there any other questions?
I think the other thing I just want to mention, and Joe, correct me if I'm mistaken, is that so when writing software for the thin library, we would only need this code generator if we're writing directly to using the thin library. If we were to use services, for example, we wouldn't need to use the generator. Is that true?
I'm not sure what you mean by only generating services. This
if I were to be not creating my own service, as an example, but using a service?
Oh, this would generate the client side as well. So if you already had a service up and running and you wanted to write a client to exercise that service, this will generate the client side code as well. So you could use only half of the output. Suppose you'd written your service in C++, and then you wanted to have a thin client to utilize that service. Then you could use the code generator. It would produce both the client and the service, but then you just steal the client code from the code generator and use it to talk to the existing service written in standard client C++.
Okay. No, I think what it was I talking about was like if I'm using the thin library services like the notification producer and notification consumer, if I'm up one layer, then I use those APIs as opposed to needing to run through the code generator to generate this code.
So if we
I think you're right. I'm discussing with Abhinav here in the conference room.
Yeah, so if we have a about service, a notification service, will this also generate a sample application for those?
Not at this time. It will not generate sample apps for about at that sort of thing at that level. This is at the very basic level at this point.
Okay. Yeah, I think I just wanted the audience to be aware that AllJoyn has multiple layers. You can program to the services layers or directly to the core. And if you're programming directly to the core for the thin library, you would need this code generator. But if you're programming at the higher layer, then you wouldn't necessarily need to.
That's correct. Okay. Well, if there are no more questions, I think we're done.
Okay. Thanks, Joe, for this.
You bet. Thank you.
All right, everyone. We'll see you guys next time.